Stay strong.
Stay safe.
Stay safe. Stay safe. Stay safe.
Stay safe.
Stay safe, everyone.
Stay together.
Stay hydrated.
Fresh.
Stay strong, stay safe, stay at home. Stay at home, yeah? Stay at home.
くれぐれもお体をお大事に。
Assalamualaikum and a very good morning to everyone. I am Diana from IK Academy and I would like to welcome all of you to our webinar of the Learn with IK Live series organized by our iClub by IK community page in Facebook. Do join our community page and don't forget to invite other people so that everyone can gain something beneficial from it. Just go to the page and click join. As a friendly reminder, please register yourself through Eventbrite to make sure that you won't miss any notification for our upcoming events and as a record purposes that you have joined our webinar today. If you have any question to ask about this, just type in comment. Our crew will attend to your question. And also don't forget to type #IK Academy. I would like to say thank you to all our returning audience and to those who are new. And this is the first time that you heard about us. We are a technical training provider. At IK Academy, we train and we integrate knowledge technically. Neutrality is our priority. We are totally brand neutral with a strict focus on education. Our training programs cover power, maintenance, environment, building facilities, mechanical, electrical, project management, and more. We are committed to provide the best learning experience to everyone. We believe learning is a lifelong process. Before we proceed with our webinar, please like and share this live webinar with those who you think will be interested with our sharing today. You may click the share button and share directly to your FB page or your LinkedIn page, or you may share around the link via WhatsApp, Telegram, or any medium that you may find, as long as it can reach to as many people as possible. And also, please type #IK Academy in comment to show your support and also your presence today. So today, we will have a webinar with the title of Steam Plant Energy and Cost Saving, Internal Combustion Engine and Steam Boiler. Our invited speaker, the subject matter expert in steam boiler and internal combustion engine, will share his knowledge and experience with us today. So let me read a bit about his profile. Yeah, I am Muhammad Normarzuki bin Yaakob, graduated with Bachelor with Honours in Mechanical Engineering from the University of Malaya and is both a registered professional engineer in mechanical with Board of Engineer Malaysia since 2000, a corporate member, the Institution of Engineers Malaysia, and a member of the American Society of Mechanical Engineers, ASME. He is a certified first-grade engineer, steam boiler and internal combustion engine by the Department of Occupational Safety and Health, DOSH. He had working experiences with several companies such as Equator Engineering Sdn Bhd, Tenaga Nasional Berhad, Petronas Gas Berhad, Gas Processing Plant 5/6, and Centralized Utilities Facility. And currently, he is holding the Managing Director for a training and consultancy firm. Throughout his career, he has extensive field experience in steam boiler operation, troubleshooting, inspection, maintenance, and repair. He is the co-author for an Introduction to Steam Machinery book published by University of Malaya Publisher. So, well, we are delightful to have our Normarzuki together with us today. So, our Normarzuki, you can switch on your camera and also unmute your mic. Normarzuki? Okay.
Okay.
Assalamualaikum.
Good morning.
Good morning. How are you?
Waalaikumsalam warahmatullah. Fine, alhamdulillah.
Alhamdulillah. Okay, so to everyone here, please say hello to our Normarzuki by typing and in comment, and also don't forget to type #IK Academy. So are you guys ready for the webinar? Because I am. And again, I will appreciate your help to like and share this live show to everyone that you can think of, or probably you can share in your community page in Facebook, LinkedIn, or everywhere. So now, so that they can join us together. And if you have any questions throughout the webinar, please feel free to type your question in comment section anytime, and I will read your question accordingly once the presentation ends. Yeah. So I guess Normarzuki, you can share your slide now.
Okay.
And I shall leave the screen for you. You can continue with your presentation. So anything you can, you can call me. Just now, if let's say there is anything about your profile that I missed out, you can also tell the audience.
It's okay.
Okay, I can see your
slide. Just wait. Okay. Okay, this is, you can see my slide, right?
Yes, can. Okay, enjoy everyone. Okay, bye.
Okay. Okay, assalamualaikum and good morning to everyone. Yeah. My name is, okay, our topic today is the steam plant energy and cost savings. Basically, the boiler is part of this training, and ICE I will cover later on, yeah, with the next slide, yeah. Okay. Okay, this is about myself. Miss Diana already mentioned about my profile, but I put here again. This is the brief about my profile. I'm a mechanical engineer. I graduated from University of Malaya in 1996, considered as an OTA engineer lah, yeah. And then a professional engineer with practicing certificates, mechanical, and then first grade steam engineer and ICE, yeah, first grade engineer steam and ICE by DOSH. And then my field of expertise, basically, I'm more to the steam boilers, and then steam energy and cost saving, and then any mechanical works inspections, but I put the summary here. Okay, just a little bit about my career profile. After I graduated from university, I worked with equipment engineering for just 1 month. After that, I left as a QC welding engineer. And then from April, May to September, basically, I work as a football coach, actually, in the University of Malaya. And then I'm not doing anything. I'm just, because at the time, you know, I still have energy to play football, but not now. Yeah. After that, I joined Tenaga Nasional as a mechanical engineer, just for 4 months. After that, Petronas called me, so I need to join Petronas due to what we call scholarship bonding. Yeah, so I worked as a shift engineer for 3 years, almost 3 years. After that, worked as a plant engineer for more or less in utilities. Yeah, almost 3 years, and then I got promoted to senior engineer, taking charge for the boiler, and then. In April 2007 to October 2008, yeah, I work in centralized utilities facility. Now they call utility 𝗔𝗰𝗱𝗆𝗺𝗆𝗺 or something like that. Yeah. So I work as a resident manager for boiler and gas turbine, and then and then they add another one task as an energy manager. That's why I learned a lot about energy. But my focus today is for steam energy. I'm not expert in what we call about electrical or chiller. Don't ask me about that. For sure, I will not answer. And then after that, I moved to Qatar Petroleum. Now they call Qatar Energy. I work with corporate training department as a senior supervisor or head of technical training for Qatar Petroleums. Yeah. And then basically I worked there for 4 years. After that, I came back and joined Biobal Engineering, yeah, since February 2013 till now. And then I'm also appointed as a consultant for a company in Saudi Arabia, AQ company in Riyadh, yeah. So we are doing energy audits, yeah, for what we call for the manufacturing plant, yeah. So just a little bit about my company. Basically, my company is Biobal Engineering. We are working closely with IK, yeah, in delivering the trainings, yeah, for various training. Basically, yeah, we are. I'm the one that the instructor for an approach of practical steam boilers, operation maintenance, internal combustion engines, and then like optimizing fuels, yeah, for industrial, yeah. So we are working closely with IK, I think since 2014, maybe something like that, maybe around 10 years from now, yeah. And then they are doing very, very excellent. Yeah, they conduct the training in Malaysia, not only in Kuala Lumpur, but you know, outside Kuala Lumpur, and then we also conduct the training in Indonesia, yeah, a few years back, yeah, before COVID-19, yeah. So just a little bit about my company, because why I put my company here, because there is a relationship between my company and the what I'm doing, yeah, what I'm doing now, yeah. What I'm doing for, you know, like steam plant energy, yeah. So our vision and mission, our vision is a technical company known in the professional skill development and engineering services. Our mission, we aim to be a technical training and energy services provider of choice to organizations that seek to develop staff technical skill and enhance engineering performance. Yeah, and then objective, yeah, of the company to achieve international standard of quality for technical training and engineering services within the next 10 years. So we have 10 years time. Yeah. And then to achieve outstanding customer satisfaction for providing training and engineering services, yeah, in next 5 years. Basically, training is not our main business. Training is not our main business. We are the engineering services right now. I will show later on the project that we are doing. We has done and we are currently doing. Yeah. Our core value is professionalism in engineering services and integrity in skill development. Yeah. So we are engineering company. Yeah, we registered with like Ministry of Finance, Tenaga Nasional, 𝗔𝗰𝗱𝗲𝗺𝗆. Yeah. And then GE, we just finished the job in 2020 as for visiting engineer. I work as a visiting engineer for GE for Sultan Ibrahim Power Plant, yeah, in Pasir Gudang, yeah. And then, you know, I will talk later on about the G machines, yeah, and Boston, Linus, yeah. Some people don't like Linus, but well, it's okay for me. I'm professional. I install my equipments there, yeah. And then Eastman, I will talk about Eastman in Gebeng, yeah, Linus and Eastman in Gebeng, yeah. So, they are we solve their problem. Basically, we introduce our equipment, yeah, and then we finish. We already we completed the study for their steam energy system. The system there is very complicated, yeah. And then Samdabi Famaniaga, we upgrade their steam plant, yeah. And then Malakoff is our long relationship with us, yeah. So Bayu Bali Engineering, we incorporated in July 2001. We have begun with a training and consulting company for power plant, oil and gas, petrochemical, and manufacturing sectors. In the past 20 years, we serve for several companies, basically through our subsidiaries, yeah, not only in Malaysia, in Brunei, Indonesia, but we in Middle East and North Africa also, yeah. We are doing some training consultancy for them, yeah. And then our professional experience on consulting strength provides insight and outstanding about the challenges facing by the industries that we serve, yeah. And then in 2019, yeah, we extended the business portfolio in the steam plant energy savings system, which are focusing on reduction of the steam plant operation expenditure OPEX, yeah. Since the past 2 years, yeah, we have audited several plants and we have audited 3 contracts for energy study and upgrading steam plant in petrochemical and pharmaceutical industries, yeah. So this is our asset, yeah. Basically, our asset is our key personnel. We don't have the physical asset, yeah. Of course we have, but we are not declared here. We are not interested with the physical asset about the office, about the cars, yeah. But our our asset is our key personnel, yeah. Myself as a technical director, and then we have our principal, combustion principal is Mr. 𝗔𝗰𝗱𝗆𝗺𝗆 from. He's in India. He will come to Malaysia next week, yeah. And then Mr. Azhar, he's principal CNI, yeah. And then Mr. Azmi, he's a mechanical specialist, yeah. And then we have one Ahmad is a support resource person, Farhan is entity expert, and then we have IR Yahaya, he's a mechanical and pump specialist, yeah. So some of them they are our consultant, and then Ms. Nosarini is our marketing, yeah. So our business basically, as I mentioned, we have started with the technical training courses, but now it's not our main business, yeah. And maintenance services, yes, we did the maintenance of boiler overhaul, yeah, boiler inspections, yeah. And then this is actually our core business right now, yeah. Our core business, we are shifted from training to to steam energy improvement plan, yeah, or projects, yeah, energy, what we call, we're not just audit and pass the report to the clients and then a client cannot go out anywhere, yeah. Basically, we are one-stop center to Z, yeah. And then we provide also visiting engineer for boiler and ICE. And then and one thing is about the combustion optimizations. Yeah. Right now we are in the process of getting the purchase order for one plant in Kluang, yeah, because they have some problem with the combustion. So we already did the preliminary. And then we are doing the steam plant design review. And then we also providing the steam piping design. Yeah, currently we are in the process of, like design one of the 𝗱𝗲 company. Yeah, and then we also provide the equipment supply. Yeah, example, we supply the valve, the pipes. Yeah. Yesterday we got the order from 𝗱𝗲. Yeah, one big valve. Yeah, so my staff just sent to 𝗱𝗲. Yeah. So, let me see the steam energy. Yeah. Overview of steam energy efficiency. Energy efficiency simply means using less energy to perform the same task. It is eliminating energy waste. Yeah. And then energy efficiency brings a variety of benefits like reducing greenhouse gas emissions. Yeah. If we are efficient, we'll burn less fuel. Of course, we reduce the what we call the GHG. Yeah, and then reducing demand on the energy imports. Yeah, of course. Yeah, we as I mentioned that we burn less fuel if our plant become more efficient. Yeah, and then lowering costs and economy wide level. Yeah. Steam system accounts for around 30%, about 30% of the total energy used in industrial application for products output. Yeah, like 2 days ago, I have visited the one of the paper mills plant in Penang. Yeah, so they use a lot of steam for their dryer. Yeah, for their dryer system. Yeah. So they asked me to design what we call the steam pipe for them. Yeah. So now in the process of preparing the proposal to them. Yeah. And then steam system can be indispensable in delivering the energy need for process heating. We know that you use a lot of steam for process heating, not only for, as I mentioned, for manufacturing. Yeah. But in oil and gas, petrol, chemicals, so they use steam for process heating, example, to heating up the heat exchanger. Yeah. And then pressure controls. Yeah. And then mechanical drive. Yeah. Mechanical drive, basically, they use mainly used in the power generations, or to drive the pumps, compressors. Yeah, for mechanical drive. Yeah. And then separation of components and production of hot water for process reaction. Yes, some plant they use hot water for part of their process. Example, I'm in the process of negotiating right now with one company in Penang. Yeah, to install what we call the condensate recovery pumps. Yeah, they use hot water, so we want to integrate the hot condensate into to heating up what we call the hot water for their process. Yeah. And then efficient steam plant will give the following benefits. Energy efficiency improvement can reduce utility bills and improve plant's bottom line. Many improvements require little or no extra investment, are easy to implement, and have payback time of less than 1 year. Example, like if we operate our system properly, yeah. So we don't need to do some investment. Example for for superheated steam, we control the temperature properly, yeah. So we will gain some of the extra energy, yeah. And then strategies that increase energy efficiency often reduce operating and maintenance costs, minimizing waste and enhance productions. Energy efficient helps reduce negative impact on the environment. Yeah, of course, it will reduce in terms of fuel burning. Yeah, and can enhance corporate community relations program. Yeah. Basics in system. Yeah. Why steam? Yeah. The steam is odorless, colorless. Colorless gas is we call gas phase. Yeah. That created when water is heated to its boiling point and changes states or vaporizes from a liquid to a gas phase. Yeah. There are three principal forms of energy in the industrial process, like electricity, yeah, and then direct fire heat, yeah, like electricity. We know that electricity, we can use, like to use for heating. Example, they have electric heater, and direct fire heaters, such as like in refinery, in petrochemicals, they use the furnace, yeah, to heating up the products, yeah. And then the other one is a steam. Yeah, they can use steam also, depends on the applications. Yeah, and then direct fire energy directly transfer the heat of fuel combustion to the process. Yeah, steam has many performance advantages that make it an indispensable means of delivering energy. These advantages include low toxic, ease of transportability, yeah, meaning that steam is easy for us to transport from point 1 to point B, yeah, which is we need to design the proper piping system. And then high efficiency, yeah, like right now, example, my boiler last time in Petronas, we are using the Marchi boiler from Italy in 1996, yeah, or 1994, they designed the boiler with 92% steam to fuel efficiency. Yeah, but I came to know that they installed a new boiler in Petronas Methanol. The boiler is 2% increase, meaning that like 2% is a huge contribute to the huge in terms of saving. Yeah, high heat capacity and low cost with respect of the other alternative. Yeah. Steam hold a significant amount of energy on a unit mass basis that can extract as mechanical works through the turbine or as a heat for the process use. Yeah. And then since most of the heat content of steam is stored as a latent heat, large quantity of heat can be transferred efficiently at a constant temperature. Yeah. Which it is useful attribute in process heating application. Yeah. Of course, there is some pressure drop, but we can calculate. Example, this morning I'm in the process of calculating not say in the process, I calculate the pressure drop for point 1 to point B for one 𝗱𝗲 plant. Yeah. And then steam system operation, there are 4 categories in steam system components. Like we have the boiler itself, we call generations. And then this one, everyone looking for this one. Yeah, basically, we have the boiler man, yeah, we have the boiler driver, we have the boiler engineers, everybody are looking for the boiler, yeah, we call generation. But not many people, looking into the yeah, example, the distribution of the steam. Yeah, is it the distribution is correct or right or wrong? Yeah, and then end use, which is the end users. Yeah, the steam users. Yeah, and then the what we call the recovery. Yeah, the recovery is basically that is what I want to focus for this lecture. Yeah. These 4 areas follow the path of steam as it leaves the boiler and returns via the condenser system. Yeah. Example, this one is we call generations. Yeah. So generation, meaning that we pump the water from boiler feed water system to the economizer. Maybe some boiler they have economizer, some boiler they don't have. Yeah. That one is okay. We don't need to discuss too much here. And then they burn fuel inside the furnace. So they produce steam, and the steam go to what we call the distribution pipes, yeah, or distribution header we call, yeah. After that, they will distribute to the end users, just like heat exchanger, process heater, yeah, and then steam turbine maybe, yeah, and then some of the steam maybe they use what we call the extraction valve, yeah. And then the condensate will go to the what we call to the pipes and collect, maybe collect, or they use what we call condensate receiver tank here. They pump to the deaerator, and then the water will pump back to the what we call to the boiler as a makeup water. Yeah. So generation steam is generated in a boiler or a heat recovery steam generator by transferring the heat of combustion gases to water. When water absorbs enough heat, it changes phase from liquid to steam. In some boilers, yeah, a superheater further increases the energy content of the steam. Yeah, some boilers, in some boilers they have superheater. Yeah, the superheater meaning that we want to increase their energy. Yeah, we heating up the temperature, so energy also increase. Yeah, under pressure, the steam then flows from the boiler to the steam generator and into the distribution system, which is the pipes. Yeah, the distribution system carries steam from a boiler or generator to the points of end use. Yeah, many distribution systems have general takeoff lines that operate at different pressures. These distribution lines are separated by various types of isolation valve, pressure regulating valve, and back pressure turbine. Yeah? Like my plant last time, we have 28 megawatt back pressure turbine. Yeah, and then last year I have visited one plant. They asked me to review their what we call their energy balance. Yeah, so they have the back pressure turbine also. Yeah, the back pressure turbine basically they want to use the low pressure turbine, the low pressure steam for the process, which is for heating process. Yeah, a proper performing distribution system delivers have enough high quality steam at the right pressures and temperatures to the end use. Yeah, meaning that the distribution also need to design properly. Yeah, because like one plant that I have visited, yeah, a few days ago, they designed the steam plant, not proper design, and then one day there is dislocate the headers because of the expansion, and then for the new plant they want to engage with me to design the steam pipe for them. It's okay, so that's my job. Yeah. And then effective distribution system performance requires proper steam pressure balance, good condensate drainage, adequate insulation, and effective pressure regulation. Yeah. So in the design of the headers, ataupun like when we audit the plant, we also check for like insulations, drainage, steam trap, all these things. Yeah. And there are many different end uses of steam, such as like process heating, mechanical drive, chemical reactions. Some plant they use steam part of the process. Yeah, like my client in Gebeng. Yeah, they use a steam part of the process. And then fractionation of hydrocarbon components. This one, they heating up the hydrocarbons. Yeah. In the heat exchanger, the steam transfer is latent heat to a process fluid. Yeah. And then the steam is held in the heat exchanger by a steam trap until it is condensed, at which point the trap passes the condensate into the condensate return system. Yeah. I will explain later on that the project that I have completed, yeah, in one plant, they suffered, about the condensate problem since day one. Maybe I think maybe 5 years before I solved their problem. Yeah. So in a turbine, the steam transform its energy to mechanical work to drive rotating machinery such as like pump, compressors, and electric generators. Yeah. Recovery, the condensate return to system send the condensate back to the boiler. The condensate is returned to a collection tank or vessel. Basically, this one like like a waste. Some people they're not interested with the condensate recovery, but like me, I'm really interested. Yeah, because we know that if we recover the condensate at a good temperature, and then like we can save a lot of in terms of boiler operating expenditure. Yeah. And then sometimes the makeup water and chemicals are added here while the why other times this is done in the deaerator. Sometimes, you know, like they add chemical here and there. So there is sometimes they call condensate treatment. Yeah. From the collection tank, the condensate is pumped to the deaerator, which trap oxygen and condensable gases. Yeah. Basically, you know, for low pressure boiler, we can, you know, we can what we call, we can the quality is not so stringent compared with the high pressure. Yeah. So the boiling water pump increase the feed water pressure above the boiler pressure and inject into the boiler to complete the cycle. So meaning that after the boiler feed the boiler water what we call the water pump to the boiler, the condensate pump back to the boiler, we call the complete the whole cycle for steam plant. Yeah. So steam cost, the true steam cost, to determine the true cost of steam, we need to know more details about the system, the steam in questions. Yeah. Are we discuss steam at the point of use or at the point of generation? Yeah. Or steam at the point of generation. Yeah. From because if we talk about at use, we need to consider also the piping cost, everything. Yeah. About the steam trap installation, everything. Yeah. For the piping. Yeah. And then the pressure drop also. Yeah. And then from which boiler? Okay, which boiler that we use? We use a 5-tube boiler, water tube boiler, gas fired, biomass example. Yeah. And then at what header pressure or at what quality? Yeah. Average cost or marginal cost? Yeah. If average cost, they do they include both fixed and variable cost? Yeah. That is just the questions. Yeah. Furthermore, we must distinguish between the cost of generation and the cost of consumption. Yeah, we have two different. Yeah, meaning that the cost for generate and the cost at the consumption. Yeah. Okay, if the plant has only one steam boiler, a steam generator, uses a single fuel and has a single steam pressure level, it is relatively easy to assign a cost to the steam. Yeah. However, in most cases, there are multiple steam sources and multiple fuels. Yeah, there are also multiple steam pressure level with multiple paths by which the steam pressure is reduced. For example, steam pressure can be reduced by pressure reducing valve or turbines. Yeah, determine the true cost of steam then becomes far more complex. Yeah, maknanya if we have so like what we call the back pressure turbine, pressure reducing valve, you know, and then we generate more than one steam level in our boiler, so the cost is a little bit complex. Yeah. So example, combined heat and power system. Example, this boiler generates steam. Yeah, and then go to the what we call to this header. 200 psi uses. Example, 200 psi we divide by 50. So normally we get around what around maybe just maybe 10 bar, 12 bar, something like that. Yeah. After that, maybe they use a turbine. This one is extraction turbine. So they use the back pressure for 50 psi, and then they use pressure reducing valve. This one is from what we call from the heat exchanger. We go to the condensate example. So to calculate the cost for this one is a little bit complex. Yeah. Right. The total operating cost, fuel, power, water, chemical additive, labor maintenance, depreciation, interest, and administrative overheads are divided by the total amount of steam produced. Yeah, basically this one is the most difficult part, like labor costs, maintenance costs, depreciations. Yeah, but in general, for the fuel cost, we can estimate like this. Yeah, the fuel cost is usually dominant component, accounting for as much of 90% of the total cost. Yeah, which is normally we are using this what we call the formula, which is cost of fuel in dollar per 1,000 pounds. Yeah, of steam. Yeah, is equal to fuel cost dollar per MMBTU times by enthalpy of steam minus enthalpy of the feed water, and then divide by 1,000. Yeah, 1,000. Sorry, I tengah dulu. 1,000 is a, sorry, ada I tak nampak sikit ni. Cost measured in units of 1,000 pounds per hour. And then overall boiler efficiency, fractional, we put 90 maybe, we can calculate, yeah. So we can calculate this one, yeah, the cost of fuel, yeah. And then calculating for the cost of steam generation, in practice, it is usually sufficient to use an approximation. Cost of generations is equal to cost of fuel times by 1 plus 0.3, yeah, which is the number 0.3. Sometimes people are using 0.35, yeah, represent the typical value of the sum of the cost components. There is a, actually not in the slide, and there is another slide, I removed this one, yeah, from item 2 to 9 in above, yeah, meaning that there is some cost component, yeah. For in oil and gas facilities, however, it could be more in smaller facilities in those that use coal and biomass. Biomass and coal is a bit lower lah, yeah. Okay, but if you compare with oil and gas, yeah, but again, kita tak boleh cakap biomass is cheaper, because biomass have a different fuel, yeah, so that the heating value for biomass is much lower than the gas example, so that the boiler size need to be big, yeah, and then maybe the capital investment for that boiler is high, yeah. So factors affecting steam plant efficiency, yeah. Okay, sorry, ini ada yang 38, I nak kena remove sikit, tulis sikit lah, sebab ada 38 ni ada terlupa tadi sejak nak buang, dia ada redundant page, yeah. Baik. Factors affecting steam plant efficiency, yeah, loss due to the heat carried up the stack, yeah, by the flue gases, high excess air as measured in the flue gas analysis, yeah. This one, some plant they little bit ignore this one, yeah. Like during my time in Petronas or in the Shell example, they have very strict for what we call excess air, yeah. Last February, I'm like one plant in Keluang, they engaged with me to troubleshoot their so-called waste gas boiler, which is they use lots of fuel to run that waste gas boiler. Yeah, they just produce very little amount of boiler of steam. So I went there, I did the O2 measurement. Basically, the flue gas is very high, which is instead of normally in the design for that waste gas boiler, normally they run around 11.7, I think. But during the measurement, we noticed that the flue gas in the oxygen is around 14%. Yeah. The T or scale water site and fire site heat transfer services. Yeah, this one stack temperature can increase because of the T or scale water site and heat transfer services or fire site. Poor water circulation in comparison to fire site gas flows. Yeah. And then faulty gas baffle that permit bypassing of the heat transfer surfaces, yeah, because gas baffle basically they want to circle the what we call the flue gas, yeah. Mana semakin banyak dia punya pass, semakin tinggi dia punya efficiency, yeah. And then gas velocity through boiler too high, the draft, so that not enough time is available for efficient heat transfer, yeah. Kalau dia punya draft terlampau tinggi juga pun, dia akan reduce juga dia punya heat transfer efficiency, yeah. And then loss due to moisture in the fuel, yeah. Normally we need to be careful when we select the fuel, yeah. The calculation must be correct, yeah. If you use, we need to make sure if you buy the fuel, either we want to use lower heating value or high heating value, yeah. Loss due to the combustion of hydrogen in the fuel that form moisture and goes up to the stack as a vapor, yeah. That's why, teman-teman, if you notice that the natural gas that Petronas, we are using in our plant, some plant, yeah. Normally they use a methane, not butane or propane, because of the hydrogen numbers in the components. Yeah? Because semakin tinggi hydrogens in the composition, semakin tinggi dia punya H2O, yeah, moisture, yeah. Loss due to moisture in the air used for combustion, yeah. Loss due to incomplete combustion, like insufficient air supply, cool furnace at low load, yeah. We try to avoid the what we call the low load, yeah. Normally boiler we run at every boiler they have minimum load, a cut-off load, yeah. Poor optimization or pulverization of fuel, yeah, optimization of liquid fuel and pulverization for coal fuel, yeah. Steam boiler running with a low temperature for superior steam, yeah, it will reduce the boiler efficiency, yeah, if you run low temperature, yeah, because some people they don't know. If we ask them why you operate like this, yeah, yes, boss, we have problem this and that. Okay, for me, they just share the excuse only. If we ask about why, they don't know basically. Yeah. And then steam trap not working properly. Yeah, some plant they just steam trap is not working for them. It doesn't matter. Yeah, because they cannot differentiate. They cannot appreciate the what we call the in the condensate there is a potential energy inside that. Yeah, and then the reactor of the tank is not operating at low temperature. Yeah. Yeah, in some plant I visited, I think last January or February, they operate their boiler with the feed water around 40 degrees Celsius. Yeah, and then they, you know, a little bit surprised or shocked when I asked them why you operate like this, and they say, oh, well, this is our new design. The tank is big, blah 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 blah. I said, well. Maybe because of the designer don't understand the concept of the director of feed water tank. There is a concept basically, yeah. They just put there, okay, if you want to add a boiler, this tank is enough to cater for the next boiler. But you know, when you want to install, you know, yeah. Steam users are not operating properly, yeah. Sometimes, yeah, steam users also, the turbine also, yeah. Example, the heat exchangers, yeah. Sometimes, you know, like heat exchanger, the steam trap is not working there, and then maybe, you know, for them, no, it's okay, no problem. Yeah, because if you don't know, you talk about, you find excuses. But for me, if we calculate the return of investment, maybe it's very, very fast. Yeah. Too much blowdown, especially for continuous blowdown. Yeah, because some people, they just open the blowdown, they never check what the percentage example. And then low condensate recovery. Yeah, in one plant that I have visited, you know, they just dump the condensate in the wastewater treatment plant. Yeah, because they say, yeah, this is a condensate, you know, this is water, because they don't know that in the condensate there is energy, there is a chemical inside that. Yeah, right. And then okay, and then tips to increase boiler plant efficiency. Yeah, I'm not talking about the boiler itself, I'm talking about the whole plant. Yeah, installing an economizer to assist in recovering the surplus heat. If our boiler don't have economizer, maybe we can install the economizer. And then, of course, if you want to install economizer, your water treatment must be good, because economizer is headed tube is connected with, you know, just headed to our headers. Yeah, meaning that you cannot do the mechanical cleaning for inside the tube, example. Yeah, and then operating boiler and users and manufacturers recommended parameters. Yeah, this one is a very, very important. Yeah, improve combustion air controls. Yeah, retrofit or upgrade boiler burners or components. Improving boiler insulation to reduce the radiation and convection losses. Yeah, and then recovering heat from boiler blowdown. Yeah, and then improve condensate recovery, and then cleaning and regular servicing of boiler internal, and then adapt the and practice preventive maintenance. Yeah, this maybe there is some more, but I put just very brief here. Yeah, but last 2 years, I think before PKP, I have visited one plant in Johor. Yeah, so they asked me to to do the study, to do the energy study for their plant. They want to see how much they can save. They can do saving for their boiler plants, for the steam plant, So me and my team, we have visited, this plant. I don't want to mention the name, I'm sorry, because of I need to I cannot disclose now, So me and my team, we went there, and then we discussed with their engineers, okay. Basically, this one just what we call just an overview saja, Nanti I straight go to this one, Okay. So this one, from the audit, we can determine the details of the saving, from the audit, like fuel consumption, how much we can save the fuel, and then how much we can save the makeup water, and then how much we can save the motive steam, which is the steam that used to heat their deaerator, and something that we cannot quantify is about the boiler water chemicals, boiler water chemicals, because of normally we need to talk with the chemical supplier or chemical supplier for that plant, Normally they will not give us the detail, but it's okay. We know that there is a saving there, Like our company, we have the technology that can formulate and optimize the steam plant system. We use so-called condensate removal device and condensate recovery units, which is we design all this, So CRD and CRU are the main components that to be installed as part of plant modification to achieve the savings. The amount that we are talking about saving, we can materialize. So basically like this. Example, the boiler is like this. Produce steam, go to the users, and then sometimes they have pressurization valve, because of maybe they want to reduce the pressure for something, And then, okay, normally we close this one, it's okay, Normally it's good to close this one. And then they use a steam trap to trap the steam. Normally they use a steam trap. And then the condensate will go to the feed water tank, to the tank and pump back to the boiler. This one generation, this one distributions, And then this one is the users, and this one is condensate recovery, And then example for this polymer plant, they have 5T boiler, and then boiler efficiency around 73%, boiler capacity around basically the boiler running capacity for the I think the boiler number 3, I think, for number 1 or something like that, Basically 2 weeks ago I went there, because we have project with them. 10 ton per hour, and then operating at 10 bar, and then we basically they provide us with the data, and then we can calculate also, So we can estimate, but they have the data. They use around 1.5 million US dollar per year for the fuel, natural gas, So around maybe 6 million, 6 million, And then estimated steam cost around $21 per ton, And the feed water temperature is 105, So and then steam condensate and water makeup, steam usage around 7.5 tons per hour. Condensate return is around 3.5 tons per hour. And then they use steam to heating up the deaerator around 740 kg per hour. And then water makeup is around treated water makeup consumption around 6.8 kg, water makeup basically feed water, And then treated water is around this much lah, dalam RM3 lah, kita ambil RM3 per ton, So after we did the study, we formulate their plan, with lots of calculations, we are able to increase their feed water temperature around 12 degrees, 22 degrees basically, So from 105 to 127, And then we're able to reduce their motive steam to 380 kg per hour. And then treated water, make up water around 4,000 kg per hour, 4 ton, And then annual fuel cost from 1.5 here, we're able to, from our calculations, they can reduce to 1.5, meaning that they save around 1.5, not say 1.5, meaning that 1.46, So they reduce around 600,000, 60,000, something like that, But never mind, we can see here. So fuel saving around $60,000 per year, it's a big amount, And the water saving around 19,000 per year, and the motive steam around 40,500 US dollar per year. So total saving around 120,000 per year, for this plant. And then example project cost, project cost. We estimated the project is around 223,000,000. So the payback normally around 2 years or a little bit less than 2 years, something like that. So it is good for industry to look into this project, to this kind of project. Of course, like my company, we are also doing the combustion checking, inspections. That's we call the hanging fruits, like potential saving, meaning that, of course, like from 14% to 11.7%, the reduction is around 2.3%. It's a big amount also. It's about 1% of energy of fuel saving. In general boiler, normally we need to run dalam 1.2 up to 2%. If the O2 tinggi, meaning that you lost efficiency. Okay. And then what we propose to them, we need to change the steam trap, normal steam trap, to our steam trap system we call CRD. And then we need to reconfigure back their plants. Meaning that the condensate will go to here, and then we use what we call the flash steam to this tank. So we install the heat deck. After that, the feed water will be from here instead of from here. So the conclusion, the steam plant energy saving is very useful for the manufacturing plant that is using steam for heating process. The manufacturing industry will be able to reduce their products unit production cost, UPC, And then the paybacks for most of the steam energy savings projects are below than 3 years. It is good to look into. And then by reducing the fuel consumption, therefore the CO2 release as atmosphere will reduce tremendously, drop accordingly. This is an example. My company, we are doing maintenance services, like since the past, since PKP lah, itu sebelum tu I tak letak. Since 2020, example, we overhaul one boiler in Port Klang, that is the golden rubber hose. We overhaul boiler, pressure vessel, and then we install the installation, and then we help what we call the medical company for the registration of their autoclave, and we provide the ICE visit engineer for GE. This plant, tuan-tuan, is the biggest GE machines right now in the world. The engine itself can generate power around 500, maybe 50 megawatts, but they claim 500 megawatts. It's a huge machine. And then kita buat example the non-destructive test, hydrostatic test, and then this boiler they award the project for repair their boiler. So we are now preparing, our team preparing what we call the repair procedure to submit to DOSH, for approval. And then Famaniaga in Puchong, last year we got the project, to upgrade their steam plant, So we installed what we call the condensate pumps, steam trap, thermodynamics, yeah, flow meters, yeah, and then monitoring system, relief valve. We need to change to, because of the valve that the manufacturer that proposed cannot fit at that place, yeah. And then we use a monitoring system. And then we did the steam plant energy saving study for Eastman in Gebeng, yeah. This plant, from our analysis, yeah, they are able to save around 2.7 million a year. So I just submit the reports this week, yeah. And then number 12, we did the study and engineering also. We install our equipment just for their steam dryers, yeah, and heat exchanger. So the steam dryer, they got some problems since day one, and alhamdulillah, we were able to solve that one. But this project for Eastman is really what we call very, very challenging because of every report will go to their center in US, and the challenges, well, it's okay. It's not a big deal for me, yeah. And then Linus also, we install our CRD system. Now this week, inshallah, they will order more, yeah. And then Magenta, last time in laundry plant, we audit their plant, but we cannot materialize the projects, yeah. There's some so-called some problems. It's okay, it's okay. It's not a big deal for me, yeah. And then steam plant energy optimization study for Sintoma Kluang, yes, example. And then we did the preliminary study on heavy consumption for this plant. And then Idemitsu also, we still not complete our study yet because of they said that, okay, they have some constraint. It's okay, but we just do the preliminary. And then for biomass power plant also, yeah, in this company. So we did a study, and then, like from the preliminary, we mentioned to them that, okay, if you want to improve your plant, you need to do this, do that. And then they said, I'm sorry, I cannot convince my client to send back what we call the condensate. Yeah. And then we also provide consultancy on design designing the steam pipe for steam boiler for kilang sawit, yeah, FTV in Kuala Lipis. And then we are checking also steam trap for kilang sawit Jengkau. We provide the consultancy services for steam pipe design for Tawau refinery. So this one is a very challenging job, yeah. So this is the company that we have audited. We work with them closely. We have completed basically, yeah. Some is ongoing, yeah. And then just to share with Tuan, this is our CRD condensate removal unit, which is the type of steam trap, but it's venturi nozzle type.
Steam and condensate enters the SteamPro condensate removal device, where the condensate is first filtered out by the strainer. The filtered condensate continues to be pushed out by the steam, which enters SteamPro's customized Venturi nozzle, where condensate is removed immediately, completely, and continuously, with minimal steam loss. And any accumulated debris can be flushed out through the blow-off valve. Steam and
Okay, this one is
steam trap yang tua yang saya pasang di kilang ni. Kita nampak cantik, cantik. Maknanya rising nozzle pun cantik, dan steam trap pun nampak cantik. Ini kita pasang dah dalam 2 bulan lepas. Very nice, very nice. Yang boleh tengok, ya. Maknanya condensate nitik, ya.
Okay, so our CRD system basically producing condensates like this. Yeah, like it's not like number one condensate, what we call the mechanical type steam trap. Yeah, normally it's on and off like this. Yeah. So maintenance is more or less when you install, you will forget the maintenance for 20 years. Yeah. So this is my contact number, Tuan, for this one. Yeah, this is my contact number. My handphone is there, 019-919-6029, And my Facebook also, I'm using my full name, yeah. Mohd Normarzuki bin Yaakob, Mohd Normarzuki bin Yaakob, yeah, my email is there. And then my company website is there, yeah. So we go to our second topics, yeah, before we end up, yeah. Okay, this is what we call the internal combustion engine. Just a little bit. Okay, sorry, I'm using your time for an hour. I promised to the organizer for 45 minutes. No?
Yes.
Sorry, just give me a few minutes. Yeah.
Okay, can, no problem.
Okay, yeah.
Thanks. Yes, can.
Internal combustion engines. What is an internal combustion engine? An internal combustion engine is where the combustion process occurs internally, like diesel, petrol engine, or gas turbine. Yeah. So an internal combustion engine is a heat engine where the combustion of fuel occurs with an oxidizers, usually air, in the combustion chamber. In an internal combustion engine, the expansion of the high temperature and high pressure gases produced by combustion applies direct force to some components of the engine. The force is applied typically to the pistons, turbine blades, or nozzle, or rotor and nozzle. This force moves the component over distance, transforming chemical energy into useful mechanical energy. Yeah. So they have their family for ICE. They have continuous combustion engine, which is a gas turbine. Reciprocating engine can be like diesel engines, like petrol engines, yeah. And then another one is a rotary engine. Rotary engine ni banyak dalam aeroplane lah, basically, yeah. So small type aeroplane. It's not the big size. Big size they use a continuous combustion engine, yeah. And then reciprocating engine can be compression ignition and spark ignition engine, yeah. An internal combustion engine usually refers to the engine in which intermittent combustion, such as like 4 or 2-stroke engine, like our car, diesel ke, kettle ke, tak kisahlah, yeah. Continuous combustion like gas turbine jet engine, rotary engine using eccentric rotary design to convert pressure into the rotation motion. Typically, an internal combustion engine is fed with the fossil fuels, such as natural gas or petroleum product, example gasoline, diesel fuel, and oil. Yeah? This one example intermittent engine. Why intermittent engine? Because the piston is up and down is an intermittent process. Yeah, but of course very fast. You cannot see. Yeah, and then this one is a continuous combustion engine with a gas turbine. Yeah, and then this one is a rotary engine. Yeah. So gas turbine, we know that the gas turbine is like other heat engine, is a device for converting part of the chemical energy into useful available mechanical power. It does in a manner similar to many ways to the system used in 4-stroke reciprocating internal combustion engine. The main apparent difference is the work is accomplished in the intermittent manner in the reciprocating engine, whereas the turbine power process is continuous throughout. Yeah. So it's something like this. Yeah, this one is a service, can be the starting system, yeah, for the engine, air intake, compressor, and then this one is combustor. This one is a shaft. This one is what we call the turbine, and this one is an exhaust. Maybe we go to the what we call waste heat boiler. Yeah. So here is intake. Yeah. This one is a compressions. This one is a combustions. This one is for expansion. This one is exhaust for 4-stroke engine. Yeah. So kita tahulah untuk gas turbine, air is drawn into the compressor, usually through an filter situated in the filter house to remove any harmful solid particles from the airstream. This air is then compressed to a design figure by a multi-stage axial compressor for big size gas turbine. Small size, normally they use a centrifugal. Yeah? The hot compressed air then fed to the combustion chamber, where it mixes with injected fuel, and here the fuel burns and adds its energy to the air. The combustion process raises the air temperature to a flame zone valve, maybe around 1,500 or 600, maybe. Yeah, tak kisahlah, this temperature depend on the engine design. Yeah. And then the hot gas immediately reduces the usable values by mixing secondary air enters the combustion chamber through the properly placed hole, meaning that the combustion chamber need to reduce the temperature by there is a hole in the combustor, yeah, because the temperature maybe in the combustion chamber is around maybe like 2,000 degrees Celsius. If they not cool down, maybe it will damage the combustor material. Yeah. The hot high pressure gas mixture is then ducted down to the exhaust temperature. In the expansion process, enough energy to remove from the gas to drive The compressor, the unit-driven auxiliary, such as like auxiliary gears, fuel pump, cooling water pumps, lube oil pump, etc. And then load may be alternator or gearbox or compressor or pump and etc. Yeah. And then dia kata since there is still much heat energy in this gas, it can be used in a variety of ways, such as like air or water heating, drying, process drying, or as a hot air feed supply to the separated fired boiler or waste heat recovery. And then any of these recovery methods help to increase the overall thermal efficiency of the gas turbine. Yeah, meaning that kalau ada power plant kita kira dia punya sorry tak ingat ni, dia punya heat apa nama tu? Ya, sorry tak ingat. Ada dalam presentation saya tapi tak ingat. Saya tak cover kat sini lah. Ya, ini contoh gas turbine tadi lah. Ya, mini filter, compressor, auxiliary. Ni diesel startup ni biasa untuk turbine black start. Ya. And then this one is a combustion chamber, this one is a diesel engine, this one is what we call generator. Yeah. So gas turbine can drive centrifugal or as a compressors, reciprocating compressors, electric compressors, electric generators, or maybe centrifugal pumps. Yeah. Reciprocating engine in ICE untuk reciprocating can be classified as method of ignition, cycle of operation, number of cylinders, arrangement of cylinders, speed, and method of cooling the cylinder. Yeah. Like method of ignition, we have the spark ignition or compression ignition engine lah, diesel ataupun kita pakai petrol. Ya. And then cycle operation sama ada 2-stroke or 4-stroke. Sekarang kalau motosikal yang lama Yamaha ke, dia pakai 2-stroke lah, but now semua motor dah pakai 4-stroke, sorry. Number of cylinders, according to number of cylinders, they are classified as a single cylinder or multi-cylinder. Ya. ICE may have more than one cylinder, such as like kereta sekarang ni banyak 3 cylinders, ya, 3, 4, 5, 6, 7, 8, ya. The size of engine is designed by the cylinder diameter, bore stated followed by the length of stroke, ya. Number of arrangement of cylinder like inline, V engine, radial engine, horizontal engine, ya. Ini example untuk inline engine, ya. Macam inilah inline engine, macam kereta kita yang biasa tu lah, ya. Kalau V
Normarzuki, you still there? I think your internet. I think your internet got some.
Yeah, maybe internet.
Some lagging.
Yeah, some problem, but it's okay.
Now better. Yes, now better.
I don't have a choice, you know. Yeah, I don't know. Maybe I'm not in Zimbabwe. Maybe.
Okay, now better. Okay, now better.
So this one is V engine, yeah, and then this one engine example, yeah, and then speed normally depend on the engine. Low speed maybe up to 350 RPM, medium speed maybe up to 1,000, and then high speed maybe more than 1,000, yeah. And then method of cooling can be air cool or water cool, yeah. And then for 4-stroke engine, kata macam ni lah. This one is what we call the fuel mixture flow. And this one for petrol engine, yes. This one is a suction. This one is compression stroke. This one is combustion stroke. This one is exhaust stroke, which is the exhaust valve open lah, ya. Ini contoh lah untuk 4-stroke, ya. Satu is what we call the suction. Satu is valve buka, ya. Compression, combustion, and exhaust, ya. So the movement of the valve depend on the cam loop lah, ya. Engine little bit different scale lah, dia pakai port, yeah, which is this one is first stroke, yeah. They use intake, yeah, here. After that they compress, combustion. After that the piston go down a little bit, and then exhaust will port akan buka lah, dia akan keluar, yeah. So Miss Diana, I finished my presentation. Sorry for ICE a little bit simple compared with the steam. So okay.
It's okay, can. So probably you can stop share your screen first. Cik Marzuki, you still there? Okay.
Yeah, sorry.
Can you stop share first? Yeah.
Sorry. I need to stop sharing.
Okay. Now it's okay. So no problem. Probably we can do next session with the topic just now, more in detail. Okay, so Normarzuki, you can still hear me, right? I think your internet now is getting
Okay.
worse. Okay, so thank you, Normarzuki, for the sharing, and we hope that you all learned something just now. So to everyone here, I think we can read some of the questions. If let's say you have any question, please type your question in comment now. And as for the rest of you, if you don't have any question, just type hashtag IK Academy to follow, to show your support and also your appreciation to Normarzuki. So before we proceed with the question and to give some time for everyone to write their question, if there is any, I would like to highlight our upcoming trainings that you might be interested in as shown in the screen. Please scan the barcode shown and click on the link shared in the comment section to get more details. Okay, so let's continue with the question. I saw just now we have one question from, I think it's from LinkedIn. This one is from Muhammad Kushairi. Suddenly my internet got problem. Okay, Kushairi is asking, what would be the best efficiency for boiler? I think he wanted you to explain on the comparison for the new boiler, new technology, etc., compare to the conventional boiler. Yeah, I mean, which one is the more efficient, I think.
Okay.
That's what we wanted to know. I believe so.
Okay. Yeah, the most important thing is if someone want to buy the boiler, yeah, they need to look into the efficiency. Yeah, because of the boiler price is not expensive compared with the OPEX. Yeah, because OPEX is basically consists of maybe 90% of the running cost for 25 years. Yeah. Because example, yeah, last time in one plant, I proposed to them to use the super efficient boiler, which is they claim this boiler from Japan, basically. Yeah, they claim steam to fuel ratio, steam to fuel efficiency is around 98%. Yeah, compared with the conventional fire tube boiler is 90%. Yeah. So meaning that they can gain around 9.
Marzuki, you still there? Marzuki, okay? Sorry, everyone. I think Normarzuki internet got cut off this time. Okay. So I guess we have come to our session today. So sorry about that. Apologize on that. So for the question that you asked just now, we try to get the answer from Normarzuki and answer the question directly in the comment section. And so I guess before we end, if you are interested to learn more from IR Normarzuki, we have actually scheduled a session of 2 days physical training. One is about internal combustion engine driver course. This one is online and it's not physical. Yeah, so sorry about that. On 25th and 26th of July. And another session about steam plant energy and cost saving course. This one is also online learning, 2 days. So, but the date will be either in August or September 2022. So, if let's say you are interested, please fill up the form via link that IK Crew shared in comments to get more details about this training, and we might have some special discount if you are really interested to join his training. So thanks again to the speaker and to all of you here. Please leave some comment in Facebook and a thank you note in LinkedIn, in YouTube, and thank you note to our guest speaker today. At least we know that we share something beneficial to you. And also, please like and follow our page in Facebook, LinkedIn, and Instagram, and also join our FB community page, iClub by IK, to get latest news for our upcoming IK Live webinar series and also other content sharing. So, last but not least, please check your email for a thank you email via Eventbrite to get the link and barcode to retrieve your e-certificate, and don't forget to claim it within 3 days. Well, I hope I can see you again. Thanks from me, Diana from IK Academy. Before you leave, please watch this video from all of us from IK Academy. Bye-bye, everyone.
Hi everyone. everybody. Hi guys.
Stay strong.
Stay safe.
Stay safe.
Stay safe, everyone. Stay together. Stay hydrated. Stay strong, stay safe, stay at home, ya. Stay at home.
くれぐれもお体をお大事に。